Hello and welcome again to another edition of Astronomy Spotlight. This month we are focusing our spotlight on one of the most exciting missions of 2021. It is the Mars 2020 Perseverance mission. Now, the Perseverance rover launched successfully July 30th, 2020, and it is scheduled to land February 18th, 2021 at approximately 2:30 p.m. Central Time. Now, the Mars rover carries some 23 cameras, 19 of which are on board the rover itself. There are an additional 4 cameras that are on the back shell and the descent stage, which will give us the best you are there view of a landing of a Mars rover ever. Something very exciting that engineers and everyone is quite honestly looking forward to. The main purpose of Perseverance is to find evidence of past microbial life on the red planet. Now, Perseverance will land somewhere in a 28-mile wide impact basin called Jezero Crater, which scientists believe was once an ancient river delta. In fact, quite possibly was an oasis 3 to 4 billion years ago. It is thought that a river once flowed into the body of water that filled in the crater, and that sediments of carbonate minerals and clay were deposited there. Scientists are hoping to find preserved evidence of organic molecules as well as other signs of microbial life. It would certainly be an exciting thing if it did. The Perseverance team believes that Jezero Crater may be one of the best places on Mars to find this evidence of life or past life on the red planet. The cameras on the rover, and as I said, there are 19 altogether on the rover itself. There are hazard avoidance cameras, which, of course, are there to avoid hazards. They're called HazCams for short. There are also navigation cameras called NavCams to help drive the rover on Mars. These cameras are also significantly better quality than past rover engineering cameras. They are now 20 megapixels versus the 1 megapixel cameras that were on Curiosity, Spirit, and Opportunity. They're also full color, and instead of black and white, they also have stereo 3D capabilities as well. There is also a cache cam, which will study samples collected very up close. Now, the science cameras, as well as the other instruments, include the Mastcam Z. It is a pair of twin cameras that, for the first time, will take high-definition color images, video, 3D stereo images, and it also has a very powerful zoom lens. In fact, the Z in Mastcam Z stands for zoom. The zoom is so good that it can spot a common fly from about 120 yards away, which is about the standard length of a soccer field. The Mastcam Z cameras are going to be the main eyes on this particular rover. As you see this image here of the pre-installed Mastcam Z, you'll see a pocket knife right there, and that is just to give it a sense of scale. There's also the Supercam. Supercam is an instrument that uses a laser to fire pulses at mineral targets that are over 20 feet away from the rover itself. And these targets are going to be 1 millimeter in size. So a very, very small and very precise laser. The vaporized rock will then be analyzed by its camera and spectrometers for evidence of organic compounds that might be a sign of past life on Mars. Pixel, the planetary instrument for X-ray lithochemistry, will use an X-ray spectrometer to search for organic compounds in rocks, which might be indications of past life at an extremely fine scale. It also has a camera to take super up-close pictures of rock and soil sample textures. For better context, it can see features about the size of a grain of salt, Finally, there is Sherlock and Watson. Yes, you heard me correctly. Sherlock is the scanning habitable environments with Raman and luminescence for organics and chemicals instrument. Quite a mouthful. Like the Supercam, it also uses spectrometers, a laser, and a camera to search for organic compounds and minerals, which have been modified by a watery environment. It can also work both day and night. Just like the character of Dr. Watson, the Watson camera aids Sherlock as it helps to solve long-standing mysteries of Mars. Sherlock will take extreme close-up images of targets, while Watson will take wider image views, giving greater context overall to what Sherlock is studying. Now, other science instruments include MEDA, M-E-D-A, the Mars Environmental Dynamics Analyzer, which will study the weather on Mars, collecting information on temperature, wind speed and direction, radiation levels, relative humidity, and the amount and size of dust particles. Information that will certainly come in handy to future Mars missions, especially with humans being involved. Speaking of future human exploration on Mars, the Mars Oxygen in Situ Resource Utilization Experiment, aka MOXIE, is going to make oxygen from the carbon dioxide atmosphere on Mars. This is how human explorers of the future will create oxygen, which they're of course going to need to breathe, as well as to create rocket fuel to get back to Earth. It is a small-scale experiment. MOXIE is about the size of a car battery. Future oxygen generators will need to be about 100 times larger than this. RIMFAX is the radar imager for Mars Subsurface experiment. It is a ground-penetrating radar that will see below the surface of Mars to a depth of 30 feet, depending on the materials. This will give us high-resolution information about what really lies below the surface of Mars for the first time. It will be able to detect the presence of water and ice down to 30 feet as well. Finally, attached to the belly of Perseverance is the Mars helicopter called Ingenuity. It's really a very small kind of mini helicopter. And the purpose is to demonstrate powered flight on another planet, which has never been attempted before. The Martian atmosphere is extremely thin, and so the challenge is to generate enough lift on the planet with an atmosphere 1% as thick as the Earth's. So the helicopter must be extremely light. In order to accomplish this challenge, the counter-rotating blades on Ingenuity will spin at about 2,400 rotations per minute. This small autonomous aircraft weighs just 4 pounds. Not bad, considering it holds computers, navigation sensors, one black and white, one color camera, wireless communication system, solar-powered rechargeable batteries, heaters, and rotor blades with a wingspan of about 4 feet. The Mars 2020 Perseverance mission is scheduled to last at least 2 Earth years, which is about 1 Martian year. But it may well last far beyond that, as we've seen with Curiosity and Spirit and Opportunity. For more information, you can visit NASA's Perseverance mission website, and there are several. One of them is mars.nasa.gov/Mars 2020. Thank you for joining me, and join me again next month for another edition of Astronomy Spotlight. I'm Kirk Rosberg, Planetarium Coordinator.